theta as cylindrical coordinates. Okay, but you have another angle here. Phi is the angle that you make with the positive z-axis. Phi is this angle here, which it kind of looks weird, but because you're starting from the upper position and going down. But one advantage of that one, the big advantage is it works really well with spheres. But another advantage is it works really well with cones. So, like for example, if you had like phi equals pi over 4, that equation right there alone would represent this cone right here, where that angle is pi over 4. Okay, going down this way is also pi over 4. Okay, and then so that's going to be a cone, where angles on all sides are pi over 4. Okay, so that alone it's just going to be a cone. I'm just pointing that out. Also, another thing about phi is always, or say, it can't be more than pi. Okay, in fact, pi. So because pi is going to put you all the way down to there. And if you go further, then you could have just taken the angle the other direction and been less than pi. Okay, so going further just puts you over here, and then you could have just taken a lower angle from the exact opposite side to get to the same point. Okay, so phi is between 0 and pi. Okay, and it's this angle here. Rho is, okay, so here r was like the distance from the z-axis, right? R was the distance from the z-axis. Rho is the distance from the origin to wherever point you're talking about. Okay, so the advantage of rho of using rho would be that if you had like rho equals 4, okay, that is a sphere of radius 4, centered at the origin. Okay, just that equation right there. So this is a cone. So phi is equals pi over 4 is a cone. You can make larger angles and have different cones, or smaller angle, and angles like that is going to give you cones. And then rho equals 4 or rho equals 5 is going to be a sphere. The radius is going to be equal to the rho. Okay, now the tricky thing is that this right here is the volume. All of this is the unit of volume. So you've got rho squared and you have a sine phi. Okay, and the reason is they give it in this diagram right here. We're not going to get too much into that. But the idea is you have this dV right there, and then f of rho, theta, and phi, and then you can integrate this way. Typically, this is how things are going to play out. Right here, you could have, theta, you could have a function. You could have a function in rho to another function in rho. Okay, things like that could happen. Okay, so that's the introduction to spherical coordinates. So essentially, one last thing is that you go in this order. So X, Y, Z, rho, theta, phi is the order. Rho, theta, phi. Rho, theta, phi. Okay, so once again, the order is rho, theta phi. Okay, so let's look at the top, number 1. And we're supposed to plot the point whose spherical coordinates are 6, pi over 3, and pi over 6. And then we're supposed to find the rectangular coordinates. Okay, so let's take a look at the plot. Let's say that's the z-axis. Here we have the y-axis, and then we have the x-axis coming out this way. And so 6 is the row, and so we'll put that on later after we put the angle. So first of all, let's go with the angle. Theta is pi over 3, right? And so, and we know that if we have it like this, then we know the pi over 3 is right there, right? So that means that going from x to y, the pi over 3 is going to be like right there. Okay, so this is pi over 3. And I probably should have done dotted lines. Dang it. Okay, and then phi is pi over 6. That's the angle that you make with the z-axis. Okay, so that's going to be like right here this way. That's pi over 6. And so this right here is going to be this row here. This distance right here is going to be 6 from the origin out to the point. Okay, so that would be where the point is, 6 pi over 3, pi over 6. Okay, so let's see here. Which one of those? Which one is it? Let's see here. Let me pull up exercise.
The second one.
The second one?
Yeah.
The top right?
Yep.
Yeah, so that's going to be the top right. Okay, good. Now for the, we also want to find the rectangular coordinates. So you can use these formulas here at the top if you want. So x is rho, so that's using this one. Sine phi, that would be sine of pi over 6, cosine of pi over 3. Whoa. Well, let me do a couple of references. So pi over 6 would be this one. And then pi over 3 would be this right here. Okay, so sine of pi over 6 would be 1/2. Cosine of pi over 3 would be also 1/2. Oh, interesting. Oops. So that would be 3 over 2 for the x. And then y is going to be 6 times sine phi, sine theta. Wait, phi is pi over 6, I'm sorry. And theta is pi over 3. So sine pi over 6 would be 1/2. Sine pi over 3 would be root 3 over 2. Three over 2. And then z is going to be 6 times the cosine of pi over 6. Times, so that's going to be 6 times root 3 over 2. That's 3 root 3. Okay, so we have 3 halves, 3 root 3 over 2, and 3 root 3. Okay, so that's the coordinates of this point in spherical coordinates. No, I'm sorry, and this is rectangular coordinates. This is spherical, and this is rectangular. Okay, you could also probably argue by just looking at the angles and stuff right here, of what these values would be. You could also try to argue that way. But I mean, it's going to be the same thing as using the formulas here. Okay, so let's take a look at the next problem. Here you want to, oh, there's a second part to that. I'll let you guys do that. I think you guys won't be that hard for you. Let's look at part 2, number 2. So change from rectangular to spherical. So here we have this first one. We can probably a good idea to graph it. 0, -2, 0. So it looks like we're back here at -2 right there. And there's the point right there. Okay, so we're looking for, once again, the order is rho, theta, and phi. Okay, so first of all, what is the rho going to be? For this one? Okay, so how far away from the origin is this point? The distance between, oh, I didn't put the parentheses. I think it's probably confusing because I didn't put the parentheses there. Okay, sorry. Okay, no, there we go.
2, right?
2. It's just going to be 2 because the distance from that and origin is 2. So over here, rho is just going to be the square root of the sum of all of these squared, right? Which is the square root of, what, 4, which is 2. So here rho is going to be 2 for this one. Okay, now what's theta?
Shoot.
So here's the positive x-axis. Going towards the positive y-axis, it goes that way. We go around here to the backside, and then we come all the way back to there.
Be 3 pi over 2.
Yes. 3 pi over 2. And then phi, this is the angle that you make with the positive z-axis. So coming down here, let me do it in blue. This angle here. From the positive z-axis all the way down to the negative y-axis. What's the angle between? In other words, what's the angle between the positive z-axis and the y-axis? It's just going to be pi over 2. Okay, that's a right angle. Okay, so let's try that. So 2, and then 3 pi over 2, and then pi over 2. Okay, so there's that one. Okay, do you want to do part 2 together? You already have the rho. We should probably do the rest of this because, I don't know, this could be pretty hard. So the rho is 2. Let's see here. I hope I can figure it out. So there's C. Okay, so now you've got -1 in the z direction. Oh, that's just great. So you're coming down this way. And then you're going 1. No, wait. That's not Z first. Hold on. Okay. Let's do it over here. Okay, so we have the Z-axis up here, the Y-axis coming out this way, and the X-axis coming out this way. Okay, now, -1 corresponds to the X-axis. What was I thinking about the Z? Okay, so let's say we have, here's -1 in the X-axis, and then 1 is the Y-axis, so you're going to come out this way, line up by 1. And then -√2 is the Z. So you're going to go down to, and there's the point right there. Oh, man. Okay. So, what is this distance from here to here? That's √2, right? Because that's -1 and that's 1, right? Okay. So hold on a second. I got distracted. We're supposed to be figuring out what is theta first, right? Theta. And that's going to be this angle here. Okay, but what is this angle here? See, this is going back 1, so -1 and then a 1 this way, right? What's this angle here? So this side is 1 and that side is 1. So what's that angle?
Oh shoot.
Okay, if we look at it this way, and say that's the x-axis and this is the y-axis. Okay, so this axis, the x-axis is this one right here, and this going back this way is this one. And so we're actually, or just like look at these 2 points here, going -1 this way and up 1 that way. That angle is the same as that one. So this side is 1, that side is 1. So this angle is pi/4, right? Which means this green angle is what? Which is this angle here. Okay, that's 3pi/4. That's 3pi/4 because the whole thing is going from all there to there is pi, right? Okay, now this is √2. This right here is also a side of √2. So these are the same. Okay, so now if we form that ray from there to there, from the origin to there, what's this orange angle going to be? Okay, we know that this is pi/2, is square root of 2, and this is also square root of 2 right here. Going from z down to just on the green line is going to be pi/2. It's going to be 90 degrees, and this is going to go, and this is going to be an extra pi/4. So that's also 3pi/4. Let's try that. Okay, yeah, so this is 2, 3 pi over 4, 3 pi over 4. Okay, let's look at the next exercise, number 3. Actually, number 4 is there also, but let's just do number 3 because we're kind of low on time. Solid lies above the cone and below the sphere. Write a description in terms of inequalities involving spherical coordinates. Okay, so you need to find limits on phi and rho. And theta is just going to go from 0 to 2 pi. Okay, so above the cone. What did I say the equation of a cone was? Or this kind of cone? Well, you know, this is z equals r, but we're not doing cylindrical coordinates, so we're not allowed to do that. But you can get it in terms of just c. Okay, so the equation of the cone is phi equals pi over 4. So if this is the positive z-axis, then coming down here on different sides, you have different angles of pi over 4, and going around gives you the cone, okay? Gives you the equation of the cone. And then pointing straight up is 0. So that means we're going to have phi going from 0 to pi over 4. Which looks like that one's 0 to pi over 4. And none of these are, so blah. So this is going to be the answer.
Yeah,
but let me show you how to resolve this piece right here. So the left-hand side is just rho squared, right? And the right-hand side is z, but z is this. So you have rho equals cosine phi when you cancel the rows out. That's how you get this piece here. And this one, if you look at it, if that's the z-axis, and here you have y and x, it's actually this sphere right here. It lies above the origin. Okay. So that's interesting. And then here you have the cone coming up like that, right? So it's going to be this, so it's just going to be this area inside the cone, but it's below the sphere. Whoa, that's like an ice cream cone with a little bit of ice cream sticking out of it. Come on, man, put another scoop of ice cream on the top, man. I want the red flavor. I want the strawberry flavor up on the top here. Yeah. Hey, and put another scoop on. How about the purple flavor? Yay.
Where is he hungry or something?
This is making me hungry. Okay.
Hey.
Dang it, our class time is over. It's already 10 minutes to 11. Okay, the answer to 2b, okay, was this. 2, 3 pi over 4, and 3 pi over 4. Spherical coordinates has rho, theta, and phi. Theta is the same angle as for polar coordinates and cylindrical coordinates. Okay, it's the angle in the xy plane down here. Rho is the distance between the point and the origin. Okay, so rho squared is x squared plus y squared plus z squared. Phi is the angle that you make with the positive z-axis, the angle that your point makes with the positive z-axis. Okay. And then you have these formulas up here to kind of help along. Okay, so here A is 1 and B is 2. And we're supposed to integrate over this region E, which is the shell of it's a shell of a sphere, but it's got the bottom cut out, and also it's got the positive, or the first octant is eliminated also, is also eliminated. Okay, and so here you have f of, here's x, y, z. So you just put in these values here. So this should be rho sine phi cosine theta. This one should be rho sine phi sine theta. Okay, I'm just copying off of these, by the way. And then the z should be rho cosine phi. And then your dv is this piece here. So you want rho squared sine phi. Okay, so for your dv. So so I'm switching from dx, dy, dz to these coordinates, then you have to put this on. It's kind of like with, cylindrical coordinates and polar coordinates, you had to put an r, dr, d theta instead. Okay, so we explained a little bit about that last time. Just remember that that's what you got to put. Okay, so now rho is going from 1 to 2. So that should be a 2, because A was 1 and B is 2. So basically you're going from 1 to 2. So as you go through there, it's going from 1 to 2. The radius is going from 1 to 2. Okay, the next one is theta. Okay, so theta, this angle here is pi over 2. And so it starts at pi over 2 and goes to 2 pi. Okay, so that's going all the way around. So that's going all the way to 2 pi. So all this angle here is 2 pi. And then phi, this is phi equals 0, and that's coming down. So phi, here's 0, and it's coming down in all these different directions, and it's going to pi over 2. Okay, so here it's pi over, so this angle here from this positive z-axis down to the positive x-axis, that's pi over 2. Any direction, okay, so like even if you come down to say that point right there, okay, this angle is pi over 2. Okay, it's 90 degrees. Okay, so those answers should give it to you, should give you the correct answer. Any question about that? Okay, so let's move on to the next problem, number 5. Evaluate this integral where E lies above the cone and below the sphere. Okay, so So above the cone, phi equals pi over 3. So if you come down to an angle of this is supposed to be coming up by the way, of pi over 3, I mean all the way around. Okay, so here also going to go up by pi over 3, and so on. So you're going to get so you get a cone coming up here. Okay, so let me try to. So that gives you a cone, and then if you keep going up, then the cone gets bigger and so on. Okay, so you have this cone right here coming up out of the okay, so you have this cone coming up here, and you want it below the sphere, c equals 1. So the top part is if this is 1 up here, then you're going to come down right here. Okay, so that's the sphere. So you have like again, it's like an ice cream cone again. Wow, with just it's been packed with ice cream, but there's like you could put another scoop on the top of there. Oh well. So what you need to do is figure out what the limits of integration are going to be. Okay, so rho, theta, and phi. Okay, so anybody want to take a crack at what any of these are?
I'm going to say theta is going to be 2 pi.
Yeah, 0 to 2 pi. Theta is going to go to 0 to 2 pi because there's no restriction on any of that. Good. Okay, rho is going to go from 0 to 1 because it starts at the origin and goes and it just hits the top, hits this top part, hits the dome, and that's 1 from any direction, from the origin to any direction. That's 1. Phi, what do you think phi is going to be?
0 to pi over 3.
Yes, that's going to be 0 to pi over 3 because 0 is pointing straight up, and as you come down, it said the cone is pi over 3, right? So that's where the pi over 3 comes from. So 0 to pi over 3. So great. So we got all the limits. So this is going to be 0 to 1 on the rho, 0 to 2 pi on the theta, and 0 to pi over 3 on phi. Okay, now we have y squared. So put this in for y. So that's going to be rho squared sine squared phi sine squared theta. Okay, so that's your y. Okay, then there's your z squared. So here's z, so that's rho squared cosine squared phi. That's your v. I mean your z. And then your dv is going to be all this. So rho squared sine phi d rho d theta d phi. Wow. Okay. So that's, whoa, that is just there's a lot. That is a really serious integral here. You got rho to the 6th. Dang. Let me go ahead and let me just go ahead and do that part actually. So you have rho to the 6th, right? So when you integrate that, that's going to be rho to the 7th over 7, evaluated from 0 to 1. And then the rest of this stuff is going to be what? You've got
Sine squared rho, sine squared theta, cosine squared rho. Is it rho
Yeah.
or sine rho? Then d rho a.
Dang. Dang to dang. Okay. So you have okay, this is just going to give you 1/7, right? Right here. Value from 0 to 1. Okay, and then you're going to have 0 to pi over 3. And this part right here, if you integrate sine squared, you get 1/2 theta minus 1/4 sine of 2 theta. Okay, and that's going to go from 0 to 2 pi. This part you can write as sine phi, and then 1 minus cosine squared phi. dc. Okay, so if you put a 2 pi in there, then you get pi. And then you put a 2 pi in here, you get 0. Put zeros in, that's all zeros. So we have pi over 7. That's what all that's going to be, over by 7. So all this is pi, and you're over 7, okay? And then you have the rest of it, which goes from 0 to pi over 3. And here, this is going to be sine phi cosine squared phi. Okay, that's this times 1 times that, minus sine phi cosine to the 4th of phi, d phi. Okay. Oh, by the way, I probably on the last problem, I should have told you that, too late now. I should have told you though that this one is spelled like that. Okay. If you want to like just do the spelling and put it in, and then this one is rho. And of course, this is theta, okay? Okay, so where was we? Oh, yes, okay, so we have the pi over 7 here, and now we can integrate this. You integrate that, you're gonna get cosine cubed of phi all over 3. And this one's gonna give you, oh wait, negative, plus cosine to the 5th of phi over 5. Okay, because if you take the derivative of this, we have a 3 come down, which cancels that 3. And then take the derivative of cosine, you'll get negative sine. So there's the sine, and then the negative gets canceled off. And then again, also here. And now it's going from 0 to pi over 3. Okay, so for reference, I guess we need to know what cosine of pi over 3 is. So, okay, so pi over 3 is 1/2, right? Or cosine of pi over 3 is 1/2. So that means that if you put the pi over 3 in here, you're going to get 1/2 to the 3rd power, which is 1/8. It's going to be negative though. And you put it into here, you're going to get 1 over 32. And then you subtract and put 0 in, so that's going to be negative 1/3 plus 1/5. So cosine of 0 is 1, so that you get that. Okay, so in the end, 47 over 3360 pi. Okay, great. You guys can see the screen now, right?
Yeah.
Okay, good. Any questions about this one?
Yes, one question. Rho, what does it represent again?
Okay, rho
Yeah, the pi
is,
over 3.
wait, the pi over this one?
Yeah.
This is phi.
Oh, that's phi. What does phi
Yeah.
represent? Sorry. I get
Okay,
the
so
radius and I get the second one, but that one just doesn't make sense to me.
yeah, okay, so it's kind of hard. What it is this angle here with the positive z-axis.
Oh, okay.
So I
Gotcha.
give an example right here where phi equals pi over 4. This is a cone because it's like going out in all directions from the positive z-axis, going out in all directions. You get by an angle of pi over 4, you get this cone.
Oh, okay. Gotcha. Thank you.
And yeah, and so what we have is we have a more poorly drawn cone right here with phi equals pi over 3. Okay, so let's move on to number 6 then. Evaluate this integral where E is the portion of the unit ball that lies in the first octant. Okay, so the unit ball, it's kind of like the sphere. The difference between the unit ball and the sphere is that the sphere would be equals 1, so it would just be the surface. The sphere is just the shell, just the surface of the ball. And the ball is the surface and the inside, everything all together, okay? So this one is just going to be in the first octant. So it's just going to be this part right here. This part right here. And so, again, the first thing you want to do is figure out what your limits are. Anybody want to take a crack at any of these?
Is that from 0 to 1?
Yeah, this is going to go from 0 to 1 because look, all this is rho squared, right? So basically you've got, so the equation here is rho squared less than equal to 1, which is really the same as rho less than equal to 1. So just that, okay? So if you had some other number here, like 49, last time we had 49, right? So it was rho less than equal to 7. But this is just a 1, so it's rho is between 0 and 1. Great, okay, what about theta?
0 to 2 pi?
Okay, this one's going to be 0 to pi over 2.
Pi over 2. Oh.
Because it says first octant. Okay, so
Oh.
first octant. First octant means that it's just here. So this is 0, and then this is pi over 2. This angle here. Okay, it's kind of it might be kind of hard to visualize it here, but if you just kind of rotate this around, this would be this part, this would be this part, and that's pi over 2. Okay, so first octant means you just this area here, just right in there. So here in this one, we have quadrants, right? Quadrants, 1, 2, 3, first, second, third, and fourth quadrant. But with this one, since we have the z-axis also, then we have 8. It splits it up into 8 octants. And this is the first octant. Okay, so theta goes from 0 to pi over 2. Okay, what about phi?
0 to pi.
Actually, 0 to pi over 2.
Oh.
Because that's a really confusing one. 0 to pi would actually put us, 0 to pi is the maximum that this can be. And so, because theta goes from 0 to 2 pi, so that's kind of confusing, but phi can only go from 0 to pi. Because if you go to pi on the phi, you're all the way to the negative z-axis. That angle's all the way to the negative z-axis. But we only want to go down to the xy plane. So that's going to be pi over 2. Okay, so let's get those. So we have those right there. So now we can go ahead and set the integral up with those limits in there. So 0 to 1 on the rho, 0 to pi over 2 on the theta, and 0 to pi over 2 on the phi. Okay, now this x becomes this rho sine phi cosine theta. Here we have e raised to the x squared plus y squared plus z squared. You could substitute these in, but then you realize that x squared plus y squared plus z squared is just rho squared. So that's e to the rho squared. And then your dv is all this. So rho squared sine phi d rho d theta d phi. Okay, so that's what we got there. Let's try to simplify this a little bit. Dang, we have a phi there, and we have a theta. We have another phi there. This is okay. So we have rho cubed. Wait. Okay, so you have rho cubed e to the rho squared. Oh, dang. Okay, that's nasty. Then, I'll put the d rho there because there's no more. I can just move this all the way to there because there's no more rho. That's the only rows that there are, right? Okay, then we have a cosine theta. And then we have a sine squared of phi. Okay, d theta d phi. Okay, so we look at this part right there. And I was just lazy, so I used, what is it? Dang, I forget the name. Was it the Symbol Lab? Is that it? I just used Symbol Lab. And this is, and all this integral is 1/2 rho squared e to the rho squared minus e to the rho squared. Okay, so if you take the derivative of that, really? Yeah, so if you take the derivative of this, you're just going to get that. Okay, so if you put a 1 in, you get e to the rho minus e to the rho. So that's good. That's 0. That's e minus e, so that's 0. And then you subtract and put a 0, and that's going to be 0, and that's going to be 1. So really, this all is 1/2. So that all is just 1/2. Okay, go to reference to that one. Okay, so now the next one is if you have this cosine theta from 0 to pi over 2. The antiderivative of that is sine theta. And that is, if you put a pi over 2, then you get 1, subtract sine of 0, that's 0. So this is just 1. Okay, so you have 1/2 times the integral from 0 to pi over 2 of sine squared phi d phi. And the integral of sine squared is 1/2 phi minus 1/4 sine of 2 phi. And that's going from 0 to pi over 2. If you put a pi over 2 in, you get pi over 4, right? If you put a pi over 2 in here, you get sine pi, which is 0. And then when you put zeros in, you get 0. Okay, so pi over 8. Okay, do you have any questions on that exercise?
No.
Okay, that's good to know. Number 7. So you're supposed to find the volume that lies within the sphere, above the xy plane, and below the cone. Okay, this cone right here is phi equals pi over 4. That's an equation for this cone. And this one is rho squared equals 4, or rho equals 2. Rho equals 2. I guess I should do that in a different color. So this is rho. This is rho. Oops. Rho equals 2. This sphere. Okay, and the cone is phi equals pi over 4. So this one is this cone coming out here. Okay, this one is the sphere. Really poorly drawn sphere. And so what we're looking at is but the sphere, you're only going to look at it above the xy plane, right? Above the xy plane. So so you'll have some kind of, so this might be where it crosses through the xy plane, okay? Really poorly drawn there. Okay, so sorry about that. Okay, so basically the area that we're looking at is this area in here. Okay, so it's under the cone, below the cone, and above the xy plane, but within the sphere. Okay, so between the cone and the plane, so this is the outside boundary. This is the plane is the bottom boundary, and the cone is the top boundary. And you have this area and you have this region in here that goes all the way around the cone. Okay, hopefully you can visualize that. So now what we need to do is figure out what restrictions are. Okay, so anybody want to take a stab at one of these or all of them?
Is the first one is it 0 to 2?
Yes, that's going to go from 0 to 2. So out from the origin all the way to the wall. 0 to 2. Any direction, as long as you're under the cone and above the XY plane.
And then theta is either 0 to 2 pi or 0 to pi over 2. There you go, yeah.
It's 0 to 2 pi because that's going to go all the way around.
Right.
All the way around. Okay, and then T is a tricky one.
It's not 0 to pi over 4, is it?
Okay, 0 to pi over 4 would give us this part, going from here down to the cone.
We need the other one.
We need from the cone to the floor. We need from the cone to here. So that's going to be pi over 4.
Is it to 2? Oh, no.
So pi over 2. Right. So pi over 2. So phi equals pi over 2 is the XY plane, by the way. Pi over 2, phi equals pi over 2 is the XY plane. So you're going from the cone to the XY plane, and that's going to get this volume in here. Okay. Okay, so you're supposed to find the volume. That means that we just put this inside. We just put this one, just put that in to integrate. Rho squared sine phi d rho d theta d phi. Okay, and then rho goes from 0 to 2, theta goes from 0 to 2 pi, and phi goes from pi over 4 to pi over 2. Okay, now there's no thetas in here, right? So that's just going to be 2 pi. Okay, and then if you integrate this one, you get rho cubed over 3. That's going from 0 to 2. And then you have, then the rest of it's sine phi d phi. Okay, so this is going to be 8/3. So you're looking at 16 pi over 3. Okay, and then you're going to integrate this part, which is going to give you negative cosine of phi from pi over 4 to pi over 2. Okay, put pi over 2 in, that's 0. Subtract and put negative, and you have cosine of pi over 4. What is that, root 2 over 2? Okay, so 8 pi root 2 over 3. I'll give you guys a chance to put that in if you're on your computer. Okay, any questions about that? Okay, let's move on to the last problem for this section. Okay, so here we're given an integral, and we're supposed to change it to spherical coordinates, okay? Because if you integrate this, it's going to be really messed up. So the first thing that you might, question? Okay, so the first thing that you might recognize is this right here. If you factor a z out, you get this. So that's really z times, so that's really going to be z times rho squared, okay? Okay, right here, these limits right here, that is, so you should think of it this way. Think of it that way. So z is between these two values right here. If you square that, well, that's kind of weird. So if you just look at, okay, so hold on. I don't want to square. If you look at just this one right here, or that one for that matter, and square it, then you get that, right? Which is this, it's the sphere. So what this is telling you is that this part is the top of the sphere of radius 1, and this is the bottom of the sphere. Okay, so really, oops. So really, man, okay, I give up. I should like know when not to make drawings. Okay, so just visualize, everybody. This is the sphere of radius 1. This is the top. This is the top part of it. The top part of it. And this is the bottom part of it. Okay. This is the top. This is the bottom. And z is between. So it's basically just saying you integrate from the bottom of the sphere to the top. Around the seam right there. Okay. So so the idea is to try to figure out what this is. Okay. So the first one is the bottom of the sphere to the top. The second one is in X, right? So here you have, so this one right here. X is going from here to here. So X is between there. That's the range there. If you just look at this one, then you get x squared plus y squared equals 1. So basically, you're going from one side of to the other. So going from that side to the other. Okay. So so this one would be this back side, and this one would be this front side. Okay, so and then this negative 1 to 1, you're going all the way. So this is basically saying do the whole sphere, integrate over the whole sphere. So these limits of integration is the sphere. So it's within the sphere of radius 1. So that's going to go from 0 to 1. This is going to go from 0 to 2 pi. And this is going to go from 0 to pi. Okay, and that's going to be integrating across the whole sphere. Okay, so 0 to 1, 0 to 2 pi, and 0 to pi. This part, the z becomes this, rho cosine phi. This becomes rho squared. Okay, so here this becomes rho cubed. And so integrating that, you're going to get rho oh wait, what am I doing? I got ahead of myself here. Go away. I forgot that part. Rho squared sine phi, d rho, d theta, d phi. Okay, so now what we actually have then is you have rho to the fifth. Okay, and then when you integrate that, you're going to get rho to the sixth over 6, divided from 0 to 1. Also, there are no thetas, right? There's no theta in here anywhere. That's going to be 2 pi. So you have 2 pi over 6. So this is going to be 2 pi, the thetas, and then this is going to give you 1/6. Okay, so you got 2 pi over 6. And then what's left is integrating from 0 to pi of cosine phi, sine phi, d phi. Okay, so that's just this and this and that right here from 0 to 2 pi, from 0 to pi, I'm sorry. Okay, and then this integral is, you can integrate this to sine squared phi over 2 from 0 to pi. And if you put pi in, you get 0. If you put 0 in, you get 0. So everything is 0. Okay, so that's just 0. Boo. Or yay, I don't know. I guess we could have seen that coming. Maybe we could have seen that coming. Yeah, because right here, this is always the radius, and it's symmetric, and this is negative down. This is negative in the lower part and positive in the upper part, so they cancel each other out.
I have a question.
Yes.
On the last antiderivative,
This one?
would it, yeah. Would it be sine squared over 2 minus cosine squared over?
No. It could be an alternate way, because if you take the derivative of this, you're going to get a 2 coming down, right? Which will cancel with that 2. And then you'll have the derivative of the sine phi, which is cosine phi. So you'll have this part coming out.
Right.
So another way that you could have done this one was cosine squared phi is that. Negative cosine squared phi over 2. Wait. Yeah, you could have done that one. Because if you take the derivative there, you get a 2 coming down, which cancels that. And then that's cosine, times the derivative of cosine, which is negative sine, which will take that negative out. But that's also going to be 0.